Today I am going to solve a problem, that is remove the duplicates from sorted array. We are given with a problem statement that is given an integer array nums, and it is sorted in non-decreasing order. It means the elements are either in the increasing order or some of the duplicates are present there. We have to remove the duplicates in place such that each unique element appears only once. So we have to remove the duplicates. We need not to use any extra space. It is saying we have to do this thing in place. It means the original array itself, which is given to us, that is nums, and it is saying that each unique element appears only once. That is there should be only unique elements, and the relative order of the element should be kept the same. The order should not be altered. Whatever the order in which the elements are present there in the array, it should be the same. Now it is saying they consider the number of unique elements in nums to be k. So whatever the unique elements are present in this nums, that number will be represented by k, and that we have to return after removing the duplicates. After removing these duplicates, we have to return that number, that is k. And now the first key elements of the nums should contain the unique numbers in sorted order. So whatever the number of elements are present in that nums array in the sorted order, those it is saying that the first key elements of the in that nums array, those should contain the unique numbers, and remaining the elements means all the k elements will be the unique, means from 0 to k minus 1 index, and beyond that k minus 1 index, whatever the elements are there, obviously those are the duplicates which are removed from this array, so they will be kept at the end indices. So we do not have to worry about those order or about their order. They can be in any order. And here they have given a particular code which will test our which we will write. It will check that it will be accepted or not. And now, before going to the final approach of this problem, I will firstly discuss my intuition, my thought process, at how I had think about this problem earlier, and then I later on came with a particular optimal approach. So this is a example which I will be taking to explain. So going here, I have taken the example array from the problem statement, and this is the second example. Here the array size is 10, and there are some of the elements present in sorted order with the duplicates present. These marked elements are the duplicates ones, and we have to simply remove these particular duplicates which are marked by this color. So we have to keep these particular elements at the end, which is uh, like represented in this way. These duplicates elements will be present at the end, and whatever the unique elements are there in the sorted order, in the relative order, same, they will be kept at the starting key elements. Those are the key unique elements which we have to return as key. Now, firstly, without thinking about the complexity and all, what I think was that I have to simply take these unique elements and place at the start, and whatever the duplicate elements are, without worrying about the order of those, I have to keep those at the end. Firstly, what I will be doing is I will firstly take this array. I will try to explain that how the brute force approach is working. So I have taken I pointer here. I have taken j pointer here. Now I already know that the I pointer which is pointing at 0th index, the element which is present there, it is already unique in itself. Now whatever the next element will come, it will come at I plus 1 index. It means which is represented by this j. Now the simple thing I want to do is I want to find the next unique elements. How I will find? I have in this brute force approach, what I think was that I will take a p pointer here, and it will be started from j, and it will search ahead of this j, and wherever it will find the first unique element, it will take that and swap it with jth index element, or simply I can say with I plus 1 index element. And after swapping, simply I will keep this I and j pointer ahead by incrementing them by 1, and again this particular thing will be repeated. P will start from j, again it will start to uh, check the next unique element first, let's say from here 2. It will again take that element and swap it with jth index, that is I plus 1 index. So this is the thing which is going on. Let me tell you one here. Let me take firstly the sorted array, which will how it will look like. This is the sorted array I have taken. This is the sorted array, and firstly what will happen here, p will traverse through this j, and it will take the first unique element. So here it will find the first unique element as 1. What it will do, it will take this element and take this jth index element, it will swap it both, because actually the next unique will come here itself. What will look like, 0 is already here, 1 will come here, and then what will happen, I and j will be incremented further. Now p will be starting from j. Again it will search ahead, it will go ahead and it will see that yes, 2 is equal, 2 is different or unique from this one. So it will take this p index element, it will take this j index element, it will swap them both. They are already present 0 from after swapping in the previous case, and now here is 2, so 2 will come here and 0 will go there. So this is how the things are working. And at the end what will happen, that the array with this is the sorted array which we are seeing, all those unique elements will be appearing at the starting indices, and all the duplicates which we have removed from this array, those will be here at the last indices of this array. And without worrying about the order, they may be in any order, we need not to worry about them. We simply have to see this thing, that the k elements, unique elements, are here or not in the modified array, and then simply return that key. So this is full thing about this. Now let me take you to the code part of this. So I have written the code here itself just to explain this, the brute force approach, to explain how it is working. So this is the function implementation where I have simply put a check for the one size array, where simply no any of the removing the duplicates will be happening. So simple, you have to return 1 itself, that one unique is only there. Then I have taken two pointers, this I and j, where I is pointing to 0 and j is pointing to 1. Now j will, this particular while loop will run till the point where j is not becoming equal to n. Point where j will become equal to n, this particular loop will be ended. And here what we are doing is, we have simply every time wherever this is coming, we are taking a p pointer and then running it is starting from j until end. We are finding that particular unique element, whatever the first unique element we will found, that will be our that we will have to swap it with jth index element, and after that simply we will break, because we have found the unique element, next unique element. And when this particular loop will get ended, we will simply increment this I and increment this j likewise every time. So this is how the things are working. And after this particular loop gets ended, we at the end we have to find the number of this unique elements, and we have to return k. So at this very start, obviously the first unique element is in itself a unique, so we will start from k equal to 1 and then run a loop from first index. So this is the final modified array, and as it is done in place. So this is the same array, only it is in a sorted array. It means having the unique elements at the start, and then these are the remaining elements. So this is running, this particular loop will be basically running on this array, the same array it is, but I am just explaining here. So it will run on the same array, and it will I will be there, sorry, the k will be at the start 1, and now I will be starting from this 1, because already one unique element is there, so k is initialized with 1. Now I will start from here. If it is greater than that, I will be incremented, k will be incremented by 1. Then so as of now this k is equal to 1. So as of now, when this I is starting from here, so k will be incremented to 1, because 1 is greater than 0, so it will become now 2. When this I will be moving ahead again, and it will be again checked that is this greater than this. So yes, it is greater than this. This will be becoming 3. Then I will be moving further. Is this greater than this? Yes. Again, what will happen? This will become 4. Again, this I will come here. What will happen here? It will become 5. Now again, now if this I is coming here, and let's say in the worst case, because the 4 is also there in the duplicates, in the worst case, let's say we are not talking about the order here. Whatever can be the order. So let's say in the worst case, this 4 is here. Even if this condition is checked, so the condition will be going false. You need not to worry about that. And in that case, this particular loop will be break. So the final which we have to return, that will be k equal to 5 we have to return. This is the case. Now time complexity we see, so yes, we are here's the two nested, this particular nested loops are here. So in the time complexity, in worst case if we see, then time complexity is going to be n square. Complexity is going to be n square, because the nested loops are there. In worst case it can be n square. And obviously, if this particular is no, approach is not a better approach and square time complexity, but I have tried to submit this particular code at the start. So yes, it is submitted. The only reason it got submitted is that the constraints which are written here, those constraints are very small, like as compared to any other more constraints. So here the nums dot length means the array size is uh, going till 3 into 10 power 4, that is 30,000 elements can be there in the array. So basically we know that there are maximum like 10 power 8 operations are 10 power 8 operations can be performed in 1 second, uh, like no normally. So here the 30,000 elements are there, so as the time complexity is going till n square, it means n into n minus 1 by 2 into n minus 1 by 2. And here if we see, then based on 30,000 elements, it can be like 4.5 into 10 power 8 to 10 power 8 operations. It means basically 4.5 in 4.5 seconds 10 power 8 operations can be there. So it is barely like accepted, this particular approach. If the constraints were somewhat hard, then it might not get accepted, because this is even barely accepted. One in 1 second the 10 power 8 operations are performed. It is somewhat nearly to that, so it is getting accepted. But we can come with more better approach, like in time complexity where it can be big O of n. So when I analyze this particular brute force approach, I found that I need not to search every time ahead of this j in order to get the unique element. I can simply, because I know this array is sorted, so if I will traverse this entire array for once, then I can whatever the unique element I will found, or any element which is not equal to the previous unique, then I can simply take it and place it at the next index to a particular pointer which I can use. So I can do that thing, that I can take a pointer I here. Let me take it down. So what we can do is that we can take this I and j pointer, where this where this I pointer and j pointer will be having their own tasks. Like this I pointer will be used for having next element, is the next unique element, I should say. Unique element, having the next unique element at what index? That will be at I plus 1 index. I plus 1 index. So this will be the case. And if I see this particular j pointer, so it will be used to traverse the entire array. It will be used to traverse the entire array to get the case. Now how it will work? Let me take the sorted array here, so that we can understand more well. This is the sorted array. Now when this I will come here, what will happen when this I is here, j is here? Now j will start to traverse. J will see that is this not equal to this? No, it is equal. So j will move further. It will see that is this not equal to this? Yes, it is not equal, so we will keep it at here. So it is kept at here. Now j will move further. It will go here. Now 2 is again not equal to this one, so 2 will come here. This is the case. In simple traversal we can do this thing, because the array is sorted. So let's get to the code here, and let's implement this code. N equal to nums dot size. And now what we have to do, what we will simply do is we will take this I pointer, which we will point it at 0th index. Then we will take one another pointer j, which will start from 1, j less than n, j plus plus. So what here happening is that we will take this jth index element, and we will take this ith index element. We will take this, we will put a condition here that this nums of j, this is not equal to nums of I. Then what will be the case? This element is not equal to this. It means it is the next unique element, because it's the sorted array. We will take this element from nums of j, keep it at nums of I plus 1. We'll take this element from nums of j, and whatever wherever it is having the new unique element, and we will keep it I plus 1 index. After this, what we will have to do, we will have to increment this I. We'll have to increment this I. Firstly, we have kept this at I plus 1 index, then we can increment this I, or we can do another thing, that firstly we can increment I and then we can place that j directly at ith index. That we can also do. So after doing this particular thing, what we will have to do, we will have to return something. What we will have to return, those, that will be the number of unique elements, that will be the key. So here, let's see this, that firstly I is what it is doing. I is started from 0, so whatever the I is value at last, that I plus 1 will be our answer. How? Let me explain that. Whereas starting I is equal to 0, it is pointing at 0th index. So what it is happening, firstly whenever the first unique element it will j will have, it will be incremented, this I will be incremented for that element when the next unique element will be appearing. Next time when another element will be the unique, in that case another time the I will be incremented. So let's say i's value as start is 0, it means obviously it is pointing to 0th index. So I value is at start, that is equal to 0. Now firstly when this first element will be checked, that is first this 1 will be checked, so at that time I will be incremented to 1. When this j will be going at 2, the next unique element it has found, so it is going to 2. Then the next unique element it has found, that is 3, so it will be incremented to 3. Then the next unique element which is found, that it will be incremented to 4. This is how I is becoming equal to 4, and any input array which you will take, I value will go to a particular value, and after that you will find that the number of elements are, whatever the number of unique elements are there, it will be I plus 1. At the end, whatever the value of I will be there, we will have to return I plus 1. This is the simple uh, approach which we have followed, and it is far better and more optimal as compared to the previous approach, because it is simple analysis, that it is a sorted array, so no need to search for a particular element by going ahead. You can simply uh, see that while traversing to the array, that if any element is unique, means not equal to the previous unique. So that's the simple approach. And here we see the time complexity, so we have used one for loop which is visiting each and every element once, and in order to check the unique element, so it is taking big O of n time complexity. So time complexity for this approach is n, and yes, space complexity we can also see it is constant, because we have not used any extra space, done the things in place only. That's all about this problem. Let me submit this. That's all for this problem.